Hello, my name is Specialist Getford, and welcome to the first of my video series for the ASVAB. I'll be going over all the math concepts for the ASVAB for arithmetic reasoning and math knowledge. I'll be starting from kind of the basic stuff here. If you feel like you get it, feel free to take the quiz, and if you do great, awesome. Go to the next video. If you don't do so, great. Please feel free to watch the rest of this video. And if it still doesn't make sense, make sure you schedule some time with me so we can go over this stuff in more detail. Even if you think you understand this stuff, I strongly recommend just sitting down and just let me kind of go over and see where you're at. I want you to succeed, and that's why I'm making these videos. So let's get started. I want to go over the essence of fractions. This is one of the things that messes up a lot of people. Fractions, operations with fractions, how to use them, when it's appropriate, and overall just the intuition behind fractions. So I want to go over just how to build intuition with fractions. The intuitive part of fractions, when it gets more natural, you'll get faster with them, you'll interpret problems faster. So even if you are a great mathematician, it can't hurt to get a little bit faster on these to save yourself some time on the ASVAB for what you really need to take your time with. So let's get started. So fractions. Sorry. As a company here. So like any number, what is a number? A number measures a distance from 0. So if I were to measure the number 1, 2, 3 on the number line, that tells me a distance from 0. 1 tells me 1 unit from 0. 2 tells me 2 units from 0. Also, we have the negatives, which operate just like our positive numbers here. Negative numbers, -1 means not only a distance of 1 unit from 0, but also in the direction of left. So positive versus negative numbers and integers, they tell you not just a distance from 0, they also tell you a direction from 0. This is important when it comes to basic physics like velocity. Negative velocity, you're going to the left usually. Positive velocity, you're usually going to the right. And as we go to the right, we like to say we approach positive infinity going right, and we approach negative infinity going left. So these are the integers. Those include all the positive whole numbers, including 0, and all the negative whole numbers. But the term whole numbers, though, only refers to 0 and greater. The great thing, what we're going to talk about mostly here about fractions, when we get more into these, fractions help us represent rational numbers. So what does that term rational mean? Well, it's kind of in the name here, the word ratio. If you have a ratio of two things, it tells you a relative relationship between those two values. Ratios come in the form of, let's say, 1/2. You've probably heard of 1/2 of something, or 1/2 of, sometimes we say 1/2 of a school is boys and the other half is girls. Rational numbers can always be represented by a fraction or ratio. So, but what about the number 2? Is the number 2 rational? Well, it is, because I can represent that as a fraction or ratio. I can represent 2 as 2 over 1. You can check this on a calculator. If you go 2 divided by 1, you will get, in fact, 2. Both of these sides are equal. In fact, number 4 is 4 over 1. And if I were to include the negative numbers here, if I were to represent -3 as a fraction or a rational number, which it is, I can represent it as -3 over 1. So that is a basic introduction to what rational numbers are. Of course, there are irrational numbers. Irrational just means they cannot be represented by a fraction or ratio. Some of those numbers include things like pi, or the constant e. Or if you take the square root of something like 2. Those are examples of irrational numbers that cannot be represented by a fraction or a ratio. And like all numbers, Fractions can also be counted by, you can count groups of them, just like you can count groups of positive and negative integers. If I were to make a different number line from 0 to, let's say 3, or we'll say to 2. I want to count by halves going to 2. Here's how I would do that. I would go 0, then 1/2, and 1, because that's the same thing as 2 over 2. But we've already established that 2 over 2 is equal to 1. Count one more half, I have 1.5. This is called a mixed fraction, where you have a whole and then a fractional part. 1.5 represents half the distance between 1 and 2. If I were to go past 2 and count by halves, I would go 2.5, then 3. The same works for negative numbers. I can count halves towards the negatives. I can go -0.5, -2 over 2, but hey, we already know that's equal to -1. Anything divided by itself. That negative just tells me what direction we're going on our number line. After -1, I have -1.5. I'm getting a bigger distance, but it's just going the wrong way. It's going the opposite way towards the negative infinity. So in fact, -1, we say it's less than +1, or less than -1. -1.5 is less than -1. Then we have -2. Let's keep going. -2.5, -3. Hopefully this gives us a better intuitive idea of just what fractions are and how to find the difference between two numbers that are represented by fractions. If I were to get smaller denominations such as thirds. Thirds are a smaller denomination than halves, and you're about to see why. So there's -infinity. There's my +infinity. I want to count by thirds going this way. So I have 1/3. I'm going to do it a little bit bigger here. 1/3, 2/3, 3/3. Oh, but that's equal to 1. So I'll go ahead and put a big 1 right there. So then I have 1 1/3, 1 2/3, 1 3/3. Oh, but that's basically 1 and then another 1. So that's going to bring me to 2. Go one step further, you'll get 2 1/3. Same applies for negatives here. 1/3, the opposite direction from 0, I'll be at -1/3. One more third this way towards -infinity would be -2/3. Then I'll just go ahead and count the whole number part there. -1, -1 1/3, -1 2/3, -2. So you can kind of see the pattern here. When I hit the fullness of my denomination here, I get to the next whole number. And that is because we already know by the definition that a number divided by itself is going to be 1. In fact, I want to go over some other key identities. I'm assuming that we have some sort of experience with division on here. So I apologize for the assumptions. So some key identities and definitions. Any number divided by 1 is going to be whatever that number was. I put A for amount sometimes. So an example of that would be if I had 5 divided by 1. Or in other words, if I had 5 people in a room, I want to make one group out of those 5 people I have. Well, if I have just one group utilizing all those people, that one group is going to have 5 people. So that's a way we can think about those denominations in division. Any number divided by itself is going to be 1. How many times does 4 go into 4? goes in one time. If I had 4 people in a room and I wanted to make 4 groups, I would have 1 person in each group. So this is another key definition we have here. Also, one that's going to be really important when we get to simplifying fractions and other operations using fractions is that anything times 1 is going to be itself. So if I divide by 1, I get back itself. If I multiply by 1, I get back that same number. This also applies to if I had 5 and I were to multiply that by 10 over 10. I can think about this in another way though. I can think about it as 5 times 10 and divided by 10. Well, isn't multiplying by 10 the opposite of dividing by 10? So by dividing by 10, I just undid what I did to 5 in the first place. Oh, so I guess that whole thing would equal 5. Okay. So hopefully you're pausing this video and taking some good notes on here. I'm going to go a little bit fast. Okay. So fractions also help us represent a portion of things. So I'm going to write that down so you can write it down too. Fractions help represent portions of things. And I did kind of mention this too, the school analogy where half are boys, half are girls. So fractions aren't just numbers you can count by, but they're also portions of things. So for example, how would I find 1/5 of 20? Well, I know you can probably divide 20 by 5, but I want to go over just some intuition first. This will be helpful for the next thing I want to go over as well. So a way I could think about that is if I had something that weighed 20 pounds, or let's say 20 ounces, like a pizza that weighed 20 ounces, I were to cut it into 5 slices, how many ounces would each slice be? Well, if each fifth has to be the same amount, 1/5 is equal to 1/5. I got to make sure that's true when I assign a value to each of these fifths. If I were to go assign it to 3, and don't write this down, this is going to be incorrect here. I'm doing some bad math on purpose. If I made each one 3, that means I can't make this one 5. Those would be 2 different amounts. That's not reliable. Both of those can't be a fifth of the same number. That's impossible. So let's try 1 and stick with it. Not number 1. Not doing the 5 here. If I let's say I did 3, that means this would have to be 3, this would be 3, this would be 3, this would be 3. And to write this down, this is still bad math. So 3, 6, 9, 12, 15. I came up short. So it's got to be something bigger than 3. Let's try 4. Okay. 4, 8, 12, 16, 20. All right, so 1/5 of that would just be taking out 1 slice, which would end up being 4. Okay, so now if I were to do something a little bit more complex, let's say 3, we'll go 3/5. We'll piggyback off of our original work here. 3/5 of 20. So let's say we did a completely new problem here. We totally forgot about this problem. 3/5 of 20. And let's say we have a better number sense here and that we know how to find a fifth of 20 easily. We just say, okay, 20 divided by 5 is going to be 4. So that means if I had 5 groups of something, Each group is going to be 4. Okay? Now I want 3 of those groups. 3/5 means I have 3 of those groups. So I'll take that group, and that group. So the size of each one is 4, so 4, 8, 12. That means 3/5 of 20 would have to be 12. That makes sense. I got a bigger number for this than that. I got 1/5 of a number, and I got 4. 3/5 of that same number ought to be bigger than that. In fact, it's 3 times that one. If I multiply 4 times 3, I get 12. Well, yeah, one of something. If I had 1 of something, and I knew the value of it, if I multiplied it by 3, I'm going to have 3 times the value of what I just had. But hopefully this makes some sense. I don't want us to have to draw a circle every time we take a portion of something. So what's a way that we can do it quickly? I said I was going to reserve operations for other videos, but I feel like for the purpose of this one, it'd be good to kind of think about fractions in yet another way. And that is that the operational parts. When it comes to operations, we know that we have, what are the operations here? Let's list them. The operations that we're pretty comfortable with should be addition, subtraction, multiplication, division. You may know roots. You may know powers or exponents. You might even know factorial, which gets a little bit more handy when we deal with probability. So probability, again, is a number that is between 0 and 1. I'll go and write that definition later. Actually, we'll discuss probability right after we get through this part here. So 3/5 of 20. So a way I could do it is I could take 20 and multiply it by the representation of 3/5 of something, which is 3 over 5. I can multiply these and get 3/5 of 20. So this fraction symbol here, it really does mean division. Of course, it also helps us represent things like a half of something, or even just like the number a half or 1/5 of 1. But for the purpose of this, where I'm going to find 3/5 of 20, I am going to treat that fraction sign like a division symbol. So 20 times 3 divided by 5. So let's do this part first. In fact, a little disclaimer here, if you ever see multiplication division, and they're right up next to each other, you do one right after the other, you always read from right to left. If you were to have, and maybe you can write this down, if you were to have 20 divided by 5 times 3, you would have to do 20 divided by 5 times 3. Yes, PEMDAS, we always hammered it into our children saying you must do multiplication before you do division, but multiplication and division are kind of on the same level. Meaning that multiplying that 20 divided by 5 is the same thing as going 20 times a fifth. There's a way I can do division with fractions here. All right, so let's just get on with finding 3/5 of 20 using this method that I want us to maybe use for whenever we can. There might even be a simpler way than this, and for the next video. So 20 times 3 is 60. So 60 divided by 5, that would be 12. I know that 5 goes into 50 10 times, plus 2 more groups would be 60. 10 groups of 5 plus 2 groups of 5 is 12 groups of 5. And that's why multiplication and division are considered on the same levels, because they're both counting groups, either the amount of groups or the amount in a group. It's just doing it kind of in opposite ways. They're going different directions in that definition there. So we got 12, as we should have. All right, I want to make this video as short as possible while also giving what you need here. Okay. Oh yes, actually, maybe we should do that little remark on probability. So when it comes to probability, here's a definition for that. So what is probability? It's related directly to fractions. So probability is a number between 0 and 1, inclusive. It can be 0 and it can be 1. Between 0 and 1 that represents, represents our beliefs about the likelihood of the occurrence of an event. Okay, so probability is a number between 0 and 1 that represents our beliefs about the likelihood of an occurrence of an event, or actually, I think "or" is actually the better word there. So that's actually great if we know fractions really well. Like, let's say if I were to flip a coin, what's my belief about the likelihood of heads occurring? Well, my belief about that is 1/2. And then also with tails, I believe the likelihood of that is also 1/2. I doubt it's going to like sit on its side, assuming it doesn't ever, flip it and then just sits there without flipping one side or another. If you can do that, send me a video of that, by the way. I'd really love to see that. So 1/2 and 1/2, that's great. If I were to, have a spinner, let's say I played roulette and they took off the greens, and I were to bet on, the columns. There's 3 columns. The likelihood of each column is 1/3. Could something like 4/3 ever represent a probability of something? Absolutely not. It's bigger than 1. This would not represent a probability. If you ever deal with a probability problem and you find something that's bigger than 1, then you need to go back and check your work. So that is all I'm going to say on probability for this video. I will do more on probability later on. In fact, I love probability. It's one of my favorite subjects in math. So if you have any questions about that, I'd love to talk with you for a straight hour on probability and some of the tricks that I use to get to the bottom of a problem there. So identifying, though, when a number is bigger than 1, that's a handy skill. Also, identifying when certain numbers are bigger, certain fractions are bigger than others. So let's get a little bit of practice here with that. So let's play a quick game of which is bigger. All right. So first up, we're going to have 1/2 versus 3/4. Well, if I represent this as on a ball here, 1/2 is about that much. 3/4, cut it into fourths, and I do 1, 2, 3 of them. I can tell that's more than the half. So okay, I'm going to say that 3/4 is the bigger number there. But I don't want to do that every time. So let's go through a few more of these. Let's say I have 4/5 versus 4/6. We have the same number, but different denominations. It's like if you gave me 4 $10 bills versus 4 $5 bills. I'm going to go for the 4 $10 bills. Thank you very much. So how do I know that one is bigger than the other? Well, what's bigger? 1/5. So we know that that's bigger. 1/5 or 1/6? Well, let's take one more look back at those fifths there. Not an artist here. Okay, so that's 1/6. That's 1/5. I kind of drew it different, or drew it kind of weird. But I can tell 1/5 is going to be a little bit bigger. How do I know that? Well, I have fewer of them to make up a whole. The entire circle represents 1. 1/5 would be a lot closer to 1 than a sixth, because it's going to take fewer of those to make a whole than it would 6. 6 are going to need more of themselves to make up that whole. So I'm going to go with 1/5 is bigger, and therefore 4/5 is bigger than 4/6. It's like if you had two people running a race, and that race is just like 10 feet, and you got someone who was 7 feet tall running against someone who was 4.5 feet tall. You would hope the 7-foot tall guy would win because it would take him fewer steps. If the small guy wins, good on him. That must have been tough. So so for numbers like these, where you're comparing 4 of something with 4 of something else, whatever the smaller number is on bottom, that's going to be the bigger value there. And hopefully it makes sense why. But let's compare something like 6/7 versus 7/8. I'll go ahead and draw those the same way. Well, shoot, this is a little bit tougher. I don't have the same, yes, those are really comparable though. I have 6 denominations of sevenths, or 6 of the denomination sevenths, and I have 7 of the denomination eighths. Well, okay. Here's a way to think about this. What's bigger, 7/7 versus 8/8? Let's take a look at 2 other fractions, 2 other comparisons, and then we'll make a guess as to which of these is bigger based off that. So what's bigger, 7/7 or 8/8? Well, they're both the same size. Trick question. They're both equal to 1. They're both the same size. Okay. So maybe instead of seeing which one has more mass on it, let's try and figure out which is missing the smallest piece. Again, let's go back to the race analogy. If 2 people are running a race and one person has 5 meters to go and another person has 100 meters to go, you're gonna bet that the person with 5 meters to go is gonna be the winner. He's already there. He only has a little small sliver left to go to reach that finish line. So which of these is closer to that finish line? 6/7 or 7/8? So what is this missing? 6/7 is missing a 7th to be a whole. 7/8 is missing an 1/8 to be a whole. Which is missing less? Which whole is missing less? Well, that means which one of these is the least value here? It's gonna be this one here, because an 1/8 is smaller than a 7th. So I would go with 7/8. I'd rather be missing an 1/8 than if let's say you're gonna I hope this makes sense for your taxes too. Let's say we lived in a great society where you got to keep 7/8 of your income. Let's say the government gave you a choice. Would you rather keep 6/7 of your income or 7/8 of your income? Hopefully we would know enough about fractions to know which of those values we'd rather keep, or those portions we'd rather keep. So why did I know that an 1/8 is bigger than a 7th? Well, let's look at an extreme example here. Let's compare 1/100th versus a half. 2 is clearly, if I were to compare just the number 2 versus 100, clearly 100 is bigger than 2. But in the context of a fraction, 1/100th of something, If I were to carve out 100th of this thing right here, it would be super tight, actually even smaller than that. Maybe a tiny little sliver like that, which means that the rest of it would be 99 hundredths. If that one I filled in is 100th, the rest is 99 hundredths. Okay, well, 1/2, that means I have this whole thing to myself. That means the rest is also a half. Okay, so this might help us determine what's bigger, 99 hundredths or a half. Well, as far as 100th versus a half goes, a half is bigger. Ooh, but 99 hundredths. You're talking about this whole area. You're talking about almost the entire thing if you're talking about 99 hundredths. So in that case, I would go with the 99 hundredths because it's only missing a small, tiny little sliver. So when it comes to things like this, we're 6/7 versus 7/8. An eighth is smaller, not by much, but it's smaller than a seventh. And that's all it's missing is that 1/8. Okay, so hopefully this kind of gives us some intuition about fractions, how to interpret them. I am going to be leaving a quiz on this stuff. Make sure we nailed it. Nail it. You're going to see a lot of these comparisons here. Get good with those comparisons. Get natural with them. It's going to save you a ton of time when it comes to interpreting the problem on the ASVAB, or it's going to help you interpret your answer more smoothly. Okay, I'll see you in the next video. Good luck.